Hello everyone, welcome to my U programming club. Today we will be solving another daily Leetcode problem, and the problem's name is pseudo-palindromic paths in a binary tree. So given a binary tree where node values are digits from 1 to 9, a path in binary tree is said to be pseudo-palindromic if at least one of the permutation of node values in that path is a palindrome. Okay, return the number of pseudo-palindromic paths going from root to leaf nodes. Okay, so first of all you should be knowing that what a palindrome is. A palindrome is a number that can be will be read same forward and backward. What I mean by this is, let's say this is a number that is given to you. So if you read it from left hand side, it will be 1 to 1, and if you read it from right hand side, it will be 1 to 1. So these two are equal. So this is a palindrome. Now let's take other example, 1 1 2. This is the, let's take this path only. Okay, so let me copy this image. Okay, this is a edge here. So if you take this path only from root to leaf, it will be 2 1 1. If you read it from this side, it will be 2 1 1. If you read it from this side, it will be 1 1 2. So these two are not equal, so this is not a palindrome. But a permutation of this particular path can be a palindrome. It can be, permutation can be 1 to 1. Okay, so it is a palindrome. So this path can be considered as a pseudo palindrome. Or pseudo palindromic path. Okay, so what happens if in a palindrome, if you observe, let's say palindrome is something like this. Okay, so as you can see, it is a even length palindrome, so everything is occurring at least twice, even number of times you can say. Okay, what I mean by this is, if you divide it into half, you will be having two equal halves. 2 is occurring 2 times, which is even. 1 is occurring 2 times, this is frequency, this is number, and 1 is also occurring 2 times, it is also even. So these both are even. Let's say there is a odd length palindrome, 1 to 1. If you divide it into the middle, you are having one element at middle and two elements on both parts. So here all of the elements will be occurring even number of time except this middle one. Okay, so 2 is occurring once, 1 is occurring twice. So this is even, this is odd. Okay, so this is one observation that we are making till now. Now let's move back towards our problem statement and see what are the constraints of this particular problem. So the constraints are as follows. The number of nodes in the tree is from 1 to 10 raised to power 5. The order of scale of tree, or say size of tree, 10 raised to power 5. And the interesting thing to be noted is that the node values are ranging from 1 to 9 only. Okay, so this is a very good constraint that will help us to solve this particular problem in an efficient way. What we will be doing, first of all, we will, since we are required to go from root to the leaf nodes, we will be using depth first traversal, DFS. Those of you who are new to this DFS traversal, I will be providing a link of article describing what DFS is, and you can explore that article and then you will be able to understand how DFS works. Basically what happens is, let's say this is the tree given to you, okay, and you start from the root. First of all, you will be traversing a path till its very depth, okay, so you will not be diverting to this path and this path at the same time. Once you are done traversing this path, you will be moving back, okay. So once you came here, then you will see whether we are having any other paths possible. Yeah, it is possible. Then you will move to this path, okay. Similarly, once you are done till here, then you will move in this direction. So you will entirely explore one option and then move to another option, entirely exploring one option, one path, or say option, whichever you may prefer, one path, and then exploring other. So this is just a layman definition that I am providing. A proper definition will be provided in the article that I will be providing link for. Now let's see how we'll be counting the paths, okay. So for that, you need to be knowing a little bit about bit manipulation. Those of you who are new to bit manipulation also, I will be providing a link describing how this bit manipulation will be working. Right now what I can tell you is, we will be using XOR property, okay. So what happens is, A XOR of a number with itself is 0, okay. This is the property that we will be using. How will we be using that? Since it was mentioned in the constraints below that nodes will be ranging from 1 to 9 only, so we are having only 9 digits to represent, and you know that an integer is of 32 bit. So if you ignore the most significant bit, even then you will be having 31 bits, okay. Starting from the 0th bit till the 31st bit. So only 9 digits are required to be represented, so each bit can represent one digit. Each bit can represent one digit. So 0 to 9, no, 1 to 9 it will be. So 0 is not included, so only 9 digits are there. So starting from this 1 till, let's say this is 9, only this much part will be required from a 32-bit integer, okay. I hope I am making sense here. From a 32-bit integer, only these bits will be required to represent a 9-digit path. Path having only digits from 1 to 9. Path can be very long. It will be not the case that your path is only 9 digits long, but the path will be containing only digits from 1 to 9. That's the case. So what we will be doing is, we will be using XOR operation. uh, we will be shifting, we will be setting each, let's say, let's move back towards our example. So this was our example. So we'll be right shifting 1 by 2 for the very first node. Okay, if you right shift 1 by 2, it will be, earlier it was 0 0 1. Okay, this was the 0th bit, and this was the first bit, this was the second bit. Now you are right shifting 1 by 2, so this first bit will move towards here. Okay, now it will be 1 0 0. So this is the 0th bit, this is the first bit, and this is the second bit. Okay, it will be looking something like this. Now what you will do, you will add it to, initially your variable will be there, which will be your path, or let's say current path. It will be set to 0. Then you will XOR this number whatever you have got here with 0, or the current value of current path, which is 0 initially. Then you will be getting something like this, 1 0 0. Okay, now you will be going downwards, since you are required to traverse from root to leaf node. This is for one path I am talking about, or in particular. So now you will come here, and your current path is looking something like this. This is the binary representation as of now. So once you are done with it, you will keep XORing the values. Now when you XOR again, it will be something like this. Since for the first value you are right shifting 1 by 1. Okay, and it will be something like this, your current path. Again you will be doing XOR operation, but right now what happens is, you have got a similar value whose bit that was represented by the value that was represented by this bit is again there. Now when we XOR this particular bit with 1 again, since it is already set, it will be marked as 0. So you will be only left with this number. Okay, this number is having only one set bit. Okay, so overall what we have observed is, either it will be one set bit or it will be 0 set bit. It was in the case of odd length palindrome. Let me change the color here. Odd length pseudo-palindrome, pseudo-palindromic path. Had it been even length pseudo-palindromic path, then your this current path will be entirely 0. Since all the values that were previously set, XOR will unset them, as each number will be occurring even number of times. So there will be cancellation of the set bits. Okay, so this is the logic here, and this is what we are after. Okay, so we have to check only that whether a path is a pseudo-palindromic path or not. It will be done with the help of XOR operation and this bit manipulation technique. So let's see how we'll be implementing this approach. This is the implementation. Initially you will set your path count to 0 and declare it as a global variable. Then you will use one function to count the palindromic paths. This is the value of the current path that you will be passing. Initially it is set to 0. Okay, it means that there is no set bit, or you haven't traversed anything, haven't encountered any node as of now. Okay, then once you are done with it, this particular function will update the path count value to its latest value, and then you will be returning path count. So let's see how this function implementation goes. So first of all, what you will be doing is you will be checking if the current root is null. If it is null, then you will simply return, and if it is a leaf node, then you will add its value to the current path. How we will be adding this value? We will be XORing this particular value with the current path. One right shifted by how many number of times? Whatever is the root value, that number of times. Since the root value will be from 1 to 9 only, so it will be very well accommodated in a 32-bit integer, which is our current path. Now we will be seeing that this is, we are setting bit corresponding to current value of root, and then what we are doing here, we are checking if at most one bit is set in the current path at each leaf node. Okay, so if that's the case, then you will increment the path count, which will indicate that it was a pseudo-palindromic path. And similar thing you will be doing for your current root that is there, and you will be recursing for the left and right subtrees. Okay, so this is just a standard DFS traversal here, and then we will be returning our path count. So this is how we will be solving this particular problem. If you are still having any doubts or any queries in general, please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.